Hi, I'm Mary, and this is another magical math moment. In this video, we're going to be tackling some more trig from pre-calculus. So we're going to be kind of taking what we've done in the other two videos about unit circle and drawing angles in standard position and just going a little bit further with that. So before we start though, I want to show you a table that's really helpful, especially if your instructor does not allow you to use a unit circle or even a calculator on some of these things. So the first thing that you want to do when you get your test is make this little table, and it's going to help you so much. So the first thing you want to do is go across with angle measures. So of course we've got 30 degrees, which is pi over 6, 45 degrees, which is pi over 4, and we also have 60 degrees, which is pi over 3. Okay, so we're gonna make a little table. Hopefully yours looks prettier than mine. Man, that's rough, but you get the idea. So we're gonna talk about sine theta, we're gonna talk about cosine theta, and also tan theta. All right, here's a little rhyme to help you. Trig is as easy as 1, 2, 3. No, it's not. It's as easy as 3, 2, 1. Let's go ahead and put everything over 2. Why do we do this? I'm not entirely sure, but it looks good. I'm in Florida and it's bright here outside, so I want to put my hat on when I go outside. My hat is radical, which I don't need over 1 because the square root of 1 is 1. Now tangent is kind of the weirdest. Remember with tan that that's the same thing as y over x or sine over cosine. So let's start with the easy one. Rad 2 over 2 divided by rad 2 over 2 is 1. This one's easy as well. Rad 3 over 2 divided by 1 over rad 2. The 2's cancel. Rad 3 over 1 is just rad 3. And then over here, this is where it gets sneaky. 1 over rad 3, which when you rationalize it is rad 3 over 3. So just kind of memorize those if you can. If you forget, you can always do y divided by x. So we're going to use that as we do some of these. So we'll be going back and forth. I also want to show you another little thing that will help in regard to the signs, positive and negative, of all of the trig relationships. So a nice little moniker, if you will, is all students take calculus. These letters will help you know where things are positive. So all things are positive in the first quadrant. Over here, sine is positive. So is its reciprocal cosecant. Down in the third, the only thing positive is tangent, and then its reciprocal cotan. Down here in the fourth, cosine is the only thing that is positive, as well as its reciprocal secant. So if you can remember, all students take calculus, that will also help you as you're trying to figure out the positive and negative signs of these various things. Okay, so we're going to look over here. We have to determine what angle is going to give us the trig values that are listed when theta is between 0 and pi over 2. Now, hopefully you remember that's first quadrant. So what's nice here, everything's positive in the first quadrant. So I am looking for the angle that gives me a cosine value of rad 2 over 2. Well, I can use this to see that happens at pi over 4. Notice I'm answering in radians because my restriction is listed in radians. If this had been degrees, I would have said 45 degrees. I'm looking at secant is 2. Okay, well that's not on here anywhere, so we have to think a little bit. Secant is the reciprocal of cosine. So I'm now looking for a cosine value of 1/2. All right, let's see. Cosine is 1/2 at pi over 3. All right, tangent is next. Tangent is rad 3. From the little chart, tangent is rad 3, pi over 3. Finally, at the end, I have cosecant is 2 rad 3 over 3. That's not in my table, so I'm going to use the reciprocal buddy, sine. So I'm going to flip this over, 3 over 2 rad 3. I'm going to rationalize this. So I end up with 3 rad 3 on the top, 2 times 3 on the bottom. Hey, look at that. Those go. I'm now left with rad 3 over 2. So where is sine rad 3 over 2? Pi over 3. Look at all these weird pi over 3s. That's just silly. Hopefully, as you're doing these, you're going to kind of remember that 2 rad 3 over 3 is the reciprocal of rad 3 over 2. Okay, let's change gears a little here. If sine of 30 degrees is 1/2 and tangent of 30 degrees is rad 3 over 3, find the remaining for trig ratios values. That's hilarious that I didn't spell remaining right. So don't judge. It's been a long day. Okay, so 30 degrees, obviously I know I'm in the first quadrant. Everything's positive, which is nice. So I need to figure out cosine of 30. I'm also going to find its reciprocal secant of 30. Let's see what else. They give me tangent, so I would need to find cotangent of 30 as well. They give me sine, that means I need to find its reciprocal cosecant. And I usually like to list these in order, so pardon me for being particular about that. All right, so if we go to 30 degrees, we can just use our little table, right? 30 degrees, cosine is rad 3 over 2. Remember what we said a minute ago, the reciprocal of that is going to be 2 rad 3 over 3. A shortcut is to leave the rad 3 on top, move the 2 up, and then slap a rad 3 on the bottom. So you can just do that as a shortcut. All right, let's see. Sine is 1/2, cosecant is the reciprocal 2. And then tan 30 is rad 3 over 3. So cotan is going to flip, that's going to become rad 3. So if you're trying to find the reciprocal here, really all you're going to do is just get rid of that thing on the bottom. So it's just rad 3. If you don't believe me or you're like, wait, I don't know if I like that, go ahead and flip your value for tangent and rationalize. Multiply across 3 rad 3 over 3. Woo, they cancel. You're left with a rad 3. So if you can remember some of these tricks, that's going to save you time when you're sitting for a test or taking an exam, okay? So just be careful of that. Here is another one that you'll see. -724 is a point on the terminal side of an angle in standard form. Determine the 6 trig values. All right, so now this time it's sneaky, right? Because that's not on the unit circle. So we have to do a quick sketch of this thing. -724 is going to be somewhere around here, not to scale at all. And I'm going to label my side lengths. So here's -7, here's 24. Hopefully you remember the triple, 7, 24, 25. If not, Pythagorean theorem will do it for you. Here's my theta. So I need to figure out sine. I need to figure out cosine, tangent, and then all of their reciprocals. Cosecant, secant, and cotan. Okay, remember SOHCAHTOA from geometry. If you're not sure what's going on there, remember that sine is going to be your opposite side over the hypotenuse. Cosine is going to be adjacent leg over the hypotenuse. And tangent is going to be opposite over adjacent. So you can use those. Obviously the reciprocals are all going to be flipped. So sine in this case, opposite is 24, hypotenuse is 25. So we're going to say 24 over 25. Cosecant will be the reciprocal, 25 24ths. Cosine is adjacent over hypotenuse. -7 over 25. Flip it for the secant. -25 over 7. Tangent is opposite over adjacent. We don't want to have a negative in the bottom of a fraction, so I'm just going to pull the negative out front, 24 over 7, and then flip it around, -7, 24 for my cotan. And that's all you have to do for those. Okay, so make your little triangle, figure out what quadrant you're in, use the trig SOHCAHTOA to help you, and then get your ratios. All right. Last one. Tangent of theta is -4 and cosine theta is less than 0. Ooh, that's sneaky. We got to figure out where we are. So tan is negative, cosine's less than 0. That's also negative. So if tan is negative and cosine is negative, that means sine is positive. So that is happening up here in the second quadrant again. There we are. This is where it gets a little bit weird. I've got tan is equal to -4. That's the same as -4/1. And if I use my SOHCAHTOA, I know this is opposite over adjacent. So opposite is here, adjacent is here. Now again, this thing is not to scale. Please don't come for me. The negative is going to go with the 1 though, because the x value is going to be negative over here. We also need to figure out this hypotenuse. So we can just do that kind of quickly. Over here, we got -1 squared plus 4 squared equals the hypotenuse c squared. So I'm going to have 1 plus 16 equals c squared. That's 17. Okay, that's disgusting. We're going to take the square root. So rad 17 is our hypotenuse. Let's put that over here. Sometimes the numbers are disgusting and the books love to do this to you, so just be careful. All right, so tan is -4. Easily then I know that cotan is going to be -1/4, right? That's not so bad. Here's where it's going to get gross. Sine is going to be the opposite leg over the hypotenuse. So 4 over rad 17. Now you guys are all good mathematicians. You can't leave a radical in the denominator. So we're just going to go ahead and rationalize. And I end up with 4 rad 17 over 17. That's not very exciting. I can't do much with it. We're going to leave it alone. Cosecant is the reciprocal of sine. So we're just going to go back to this part right here. That's why it's important for you guys to write out your work. And I'm just going to flip this. Rad 17 over 4. That was amazing. All right, next we have cosine theta. So we're going to look at adjacent leg over hypotenuse. -1 over the square root of 17. Which again, we're going to have to rationalize. So we end up with negative rad 17 over 17. Now you might be tempted to try to reduce here, right? You can't do that. You just got to leave it alone. Because that's an radical, that's not. The reciprocal friend of cosine is secant. So we're just going to flip this here. Negative rad 17 over 1, or just negative rad 17. So I hope that this has helped you understand a little bit more about these different trig values and how we can use the trig and unit circle to help us figure some of this stuff out. Please feel free to like, share, and subscribe. Let your friends know about my channel so that they can learn more about Precal trig as well. And I hope you come back for another video. Thanks for watching. Bye.